probability on the SAT is not about memorizing fancy names or jargon for its own sake. It is about counting carefully, staying organized, and choosing addition versus multiplication with intention. We will go from simple, favorable, over total problems to unions, independence, and a fast trick for at least one questions. Stay calm when you see tables or two linked events. The structure repeats from problem to problem, and you can train it until the setup feels automatic instead of intimidating. Always start by checking whether outcomes are equally likely. If they are not, you must weight them differently before you divide. Start with the definition. Probability is favorable outcomes divided by total equally likely outcomes. That fraction always lives between 0 and 1. 0 means impossible, 1 means certain. If you want a percent, multiply by 100. 0.25 is the same as 25%. Easy example. A bag has 3 red marbles and 5 blue marbles. You draw 1 marble at random. The total number of marbles is 8. The favorable outcomes for red are 3. So the probability of red is 3/8. Leave it as a fraction unless the question asks for a decimal. The complement is 1 minus 3/8, which equals 5/8. That is the probability of not red. Quick sanity check. Probabilities for a full set of disjoint outcomes should add to 1. If your fractions feel off, recount before you simplify. When the problem says random and lists a finite set of outcomes, default to equally likely unless you are told otherwise. That assumption is what makes favorable over total the right starting point. Medium step. 2 events can overlap for probability of A or B. You cannot always just add. The general rule is probability of A or B equals probability of A plus probability of B minus probability of A and B. You subtract the overlap because those outcomes would be counted twice if you only add. If the events are mutually exclusive, the overlap is 0. The formula collapses to simple addition. Harder style, independent events. One outcome does not change the probability of the other. Multiply probabilities when you need both to happen. Coin flip and die roll are classic independent pairings. Probability of heads is 1/2. Probability of rolling a 6 is 1/6. Together, 1/2 times 1/6 equals 1/12. If the problem says without replacement, independence fails, and then you must update counts after the first draw. Common mistake. Adding when you should multiply or multiplying when you should add. Use addition for mutually exclusive or branches. Use multiplication for sequential independent steps. If you feel unsure, rewrite the question in words. Do I need both or do I need either? Pro tip. At least one success is often fastest via the complement. Probability of at least one equals 1 minus probability of none. This shines when each trial repeats with the same probability, like multiple coin flips or multiple guesses. On table problems, read row and column totals before you compute anything, and label whether joint counts sit inside intersections or margins. Headers prevent silent counting errors that ruin an otherwise perfect setup. Recap. First, probability is favorable over total, always between 0 and 1. Second, for overlapping events, add probabilities and subtract the intersection. Third, multiply for independent and use 1 minus probability of none for at least 1. Keep complements in your back pocket whenever at least or none appears in the wording. Practice more on NovaMaths.